So in this section, we're going to analyze quadratic functions, which is basically applications or, in other words, word problems. So I don't want you to be afraid of the word problems. I want you to break it down into things you know. So first of all, whenever possible, draw a picture. It will help you understand what's going on. Whenever you hear the words maximum or minimum, that means you're finding the vertex. We just spent a whole section finding the vertex from the equation. So if in a word problem, if it asks for the maximum value or the minimum value, that's what you're finding. If it's a minimum, it's going to be U-shaped. If it's a negative x squared, it'll be flipped over and give you a maximum. So this would give you a minimum value, that would give you a maximum value. If you see the words initial or start or stop, initial or start means you're going to be looking for the y-intercept. That's where you start. Your stop will be your x-intercept or intercepts. There could be two, but if it's a real life situation, make sure you pick the one that is reasonable or the one that's possible. Okay, so for example, we have a ball is thrown upward from the top of a 40-foot building at a speed of 80 feet per second. The ball's height above the ground can be modeled by the equation h of t equals negative 16t squared plus 80t plus 40. And then it asks us to find the maximum height of the ball, or when does the ball reach the maximum height, what is the maximum height, and when does the ball hit the ground. So basically, if you were graphing this, it's a negative 16, so it's going to be flipped upside down. So it's doing some shape like this. Your vertex is going to be your maximum height, where t is your x value and h of t is the height, is your y value. And then you've got a y-intercept, that would be the height it starts at. And then you've got two x-intercepts, but remember t here is your x value. You can't have negative time. So if we're looking for the x-intercepts, we're only going to be interested in the one that's positive time. So when you start this, let's look at the first one. Let's just look at A. When does the ball reach the maximum height? Well, maximum height is going to be, or when maximum height is going to be the time of your vertex. So what that is asking you to find is h. And recall that's negative b over 2a. So that's going to be negative 80 over 2 times negative 16, which is negative 80 over negative 32, which negative over negative makes a positive, and then 80 over 32 will reduce to 5 over 2, or 2.5 seconds. So here, our maximum height, it reaches its maximum height at 2.5 seconds. Now the next one, part B, it says, what is the maximum height? In this case, that wants the height at your vertex. So here for B, we're finding K. So remember, K is just f of h, or in this case, we're using h of t. So we're going to plug 2.5 into the equation everywhere you see a t. and you can use a calculator here. It actually comes out to 140 feet. So at 2.5 seconds, its height is 140 feet. That's its maximum height. Now the third question is, when does it hit the ground? That's going to want your t value right there on your x-intercept. So we're looking for our x-intercept here. Now, to find your x-intercept, remember you set y equal, or the equation, equal to 0. So I'm going to have 0 equals negative 16t squared plus 80t plus 40. And we're trying to find t. Remember, we need to use the quadratic formula here. So instead of x equals, I'm going to have t equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now that looks like a big mess, but I will tell you that the calculator's on your homework. You can plug this entire thing just like in that form, except you have to pick a plus or a minus into that calculator because you're getting a decimal answer. It doesn't have to be an exact answer. You can plug that into your calculator. I will tell you that in this case, the negative is going to be the correct answer, but you might have to try both. I just am not going to do them both right now. The reason I know that is I've got a negative on the bottom and a negative out in front, so I need my answer to be positive. So that means that the minus one will give you the positive answer, which when you plug that in, it gives you 5.458 seconds. And you might have to try both of them, but if you come out with a negative answer, do the other one. Okay, let's look at this other example. This one, Marcus wants to build a rectangular enclosure for animals. One side of the pen will be against the barn, so he needs no fence on that side. The other 3 sides will be enclosed by wire fencing. If Marcus has 750 feet of fencing, find the dimensions that maximize the area of the enclosure. So again, we got a lot going on here. So first thing I want you to do is draw a picture. So I've got a barn here, and he is building a fence up against it. So he only needs fence for 3 sides. He doesn't need any fence up against the barn. Okay. I also know that he wants to use 750 feet of fencing. That's going around the fence, which is perimeter. So my perimeter is 750 feet. The other things I know, let's label this. This would be a width, and that would be a length. So the perimeter would also be 2W plus 1 length equals 750. Okay, now I need to find an equation here. Well, let's start by answering the questions. Let W be the width of the enclosure and let L be the length of the enclosure. Write a function for the area of the enclosure in terms of W. So area for a rectangle is equal to length times width, but I want to just use it in terms of W. So I have to change my L into terms of W. I'm going to use this equation over here. If I solve it for L by subtracting 2W from both sides, I get L equals 750 minus 2W. So I'm going to substitute that in for L. where the L is, I'm going to put 750 minus 2W. And then that's equal to L, and then I've got the times the width. So this is area where this is L, length times width. So that's answers A. Also notice that if you multiply the W in, that gives you 750W minus 2W squared. That gives you a quadratic equation. So on part B, when it says what would maximize the area, remember our wording from earlier, if it asks for maximum, that means you're asking for the vertex. So what width would maximize the area? That means we're going to find h, which is negative b over 2a, using this quadratic formula. Now notice there's no constant, so there's no c, but I still know that negative b is with the w term and a is with the squared term. So I'm going to have negative 750 over 2 times negative 2, which would be negative 750 over negative 4. And then if you put that in the calculator, you get 187.5. So my maximum width would be 187.5 feet. So when it asks for maximum area, I'm just going to plug that back into my area equation. So this is basically wanting K, my maximum area. So I've got 750 times 187.5 minus 2 times 187.5 squared. And again, calculator gives you 70,312.5, and this is area, so it's feet squared.